Good morning, good afternoon, good evening. Welcome to Async API Spontaneous Onboarding Part 2. As usual, the live stream will start with a small delay. It's 5 p.m. here at my location, so yeah, let us give like 2-3 minutes more for folks to join the live stream. So nobody later has to follow up with the recording. So yeah, take your time if you're already watching. I can see the live stream started on YouTube. Again, just remember during the live stream, like the live stream goes to different channels, like Async API official channels like Twitter, LinkedIn, Twitch, and YouTube. But I mean, it's complex enough to follow up with Zoom chat if somebody joins on Zoom, and then so we choose at Async API to follow only chat, live chat from YouTube. So like if you don't want to join Zoom and ask questions like verbally, but on the chat, then please use YouTube for that during the live stream. Okay, let me share the screen, the link to the live stream in our Slack channel. And we will be very soon ready to start. Hi, Pedro. Thanks for joining, man.
Hey, Lucas. Nice to see you, man.
So I think like you're the only one that joined. So I think the majority prefers to just watch the live stream or watch the recording. But
Okay, no problem.
and it's 3+, so I guess I'm gonna start it. Especially that we have to finish, yeah, like in less than an hour, because then we have another live stream from Async API about a totally different topic.
Okay, cool.
So let me share the screen. So many screens. Which one? Which one? Okay. Can you folks confirm that you can see my Firefox with something on GitHub? Okay.
Yeah.
Thank you, Pedro. And also, like, if anyone is there watching on socials, then as well, please say hello, so we know it. We're not alone. Although, again, it's an onboarding that is a live stream, so automatically it's recorded. I know that few people can't join at this time and just follow up with the recording. So no worries if you couldn't make it. Whatever. So just some information for folks that did not watch part 1. So basically, this is the onboarding initiative is to have 3 sessions, like onboarding sessions for Async API users and contributors, but mainly it's focused on the contributors that started a few weeks ago with contributing to Async API as members of Google Season of Docs, not Google Summer of Code. So that's why we started it, to help out understand Async API and event-driven architectures. That's why the first part of this, like, first of all, like all the 3 parts are based on this script from that I'm storing on GitHub. So let me send the link on YouTube. Now, the part number 1 that is on our AsyncAPI YouTube channel. In this part, I was talking about basically APIs in theory. So just to recap quickly, what we discussed was that like we talked in really general what APIs are, the difference between synchronous and asynchronous APIs, basing on an example of one of the asynchronous protocols called WebSocket. Then we also tried to like explain as much as possible like the concept of protocol, because it also plays an important role in Async API itself. And we also talked a bit the specifications, like what they're for and what specifications we know for different protocols. And then, yeah, talked about event-driven architectures with some examples, like theoretical examples, but also like real-life examples from the browser perspective. And the most important, like, I don't think the most important was when I was scaring people that EDA is the most complex, but I think the most important was the examples, like the theoretical examples, not real life examples that we like, that we know from somewhere. But it was like theoretical to show like 2 different perspectives in EDA, like the most common, where you have a client and a server. So there's one, in this case, WebSocket server that sends and receives messages, like stream of messages from different clients. And we also talked about the architecture where there's a message broker in the middle. So basically, like, just look on this most complex final diagram. So basically, we talked about the architecture where for event-driven architectures, where there's some kind of message broker in the middle that makes sure that like it's responsible for delivering and orchestrating messages in the architecture. So it's receiving and sending messages to receiving from publishers and sending to subscribers. So that's what we were talking about in part 1. In case somebody wants to follow up first. Now the part 2 is about seeing these APIs, this event-driven architecture APIs in real life, in what industry they're being used. So you can, like, the idea is that you can somehow map this theoretical explanation with the real life explanation. Like, at least that's the idea. Of course, if you remember what I was talking the last time. Then we will do some hands-on. So luckily there is one API in the world. I found only one that you can use, that it's asynchronous, and you don't have to log in, you don't have to subscribe to get some authorization key. It's open to public, so it's super easy to play with it. And I will encourage you to also play with it on your own. And if there will be enough time, might be that there will be enough time, then I will do like an initial intro to Async API before part 2 of the onboarding that will take place next Wednesday, where we actually will create a real Async API document. I will create it during the meeting, will explain every part of it. I'll explain things that I did not cover in the document. And then we will do something useful with the Async API document to also show like what's the point, basically. But yeah, let's start. I hope that's fine. The most important lesson from last part was I was asking if you prefer slides or if it's okay that we're basically skipping through a script. Nobody shared a feedback that we should do slides, so that's why I still continue with the script. But yeah, let's continue. So the real life examples, there's not a lot of them, but there are, and as you can see, they're pretty focused on a specific protocol. if it comes to a publicly available APIs for different services. But yeah, let's zoom a bit to not overwhelm you with this huge table, and I will just skip through some of the categories, some of the examples to so you could get some feeling about the real life examples. So the first example of APIs of communication where event-driven architecture is pretty critical is Internet of Things. Basically, when you have a I don't know, like a heater at home, you're coming back from office to home, and you want to have home heated to a proper temperature, so it's not super cold at your home. So you just send some message from your mobile to some controller on your heater, where you say, okay, like please heat my house, and then you also receive messages back, like with the update, like what's the temperature. So that's Internet of Things. So basically managing a lot of devices, anything you can imagine. So the first one I picked because we know that they're using Async API, and also the members of the developer team at Zorabots, they also supported Async API during the Async API conference, and they were talking about Async API and IoT. So yeah, the use case. So basically, what they're doing is they're putting an API in your robots. So you can imagine many different robots. The family is pretty big. Like you have some robots that make coffee and robots that do other stuff. I'm not an expert in robots. I think me personally, I will avoid having robot at home as much as possible because I watch too much science fiction. But you can imagine like these different robots that automate stuff, can automate stuff at home. They do many things. They communicate between each other, between different systems, and the things that they do, every single move, every single operation is an update in the system. It's every single thing that they do, they generate a message. So there's a huge amount of messages that are floating in the whole system, and that's why they need event-driven architectures. The robot to do a move needs to have a message about the possibility to do a move without asking for it. Like it's basically, it has to be smooth. You should not ask if I can move. You should know that you can move because of the circumstances that occur in the system. So what you need as a developer, when you're allowing people to control robots, for example, and you're allowing to build extensions, like you want to programmatically create your own custom applications to manage the robots at home, for example, you need to expose the API to the developers. So developers basically need to know what kind of messages run in the system and what they can basically do with them, and what are the options. So Zorabots is an example, and you can see the docs that they're generating. So like there are many different messages that can happen, many different things that can happen in the system. Like you can imagine like emotion. So you need to basically have a place where you can report from every robot that there's a motion happening. So you can, for example, figure out that, okay, this particular robot is now, for example, moving, and it's moving with this speed, or it's moving, or it stopped moving, or it's where it's located, etc. So all these information is like you want to read them when you're building your own application that, for example, alerts you when robot stopped moving. So you as a creator of additional application using the API of ZoraBots, you can say, okay, like for this particular robot, I want to get an SMS message whenever robot stops working. So that's the use case, one of the use cases in IoT, and why documentation is needed, like why you need to know all this particular specific information about everything that happens in the entire ecosystem of robots in this case. Now, there are also IoT platforms that expose, usually again, MQTT protocol. So I think you can already assume, and that's what I always assume when somebody comes in to Async API and asks about like how to use MQTT with Async API. Always behind my head, I'm already like having this assumption, yeah, probably somebody's doing some IoT stuff, and that's why MQTT is there. But yeah, I'm gonna skip a few because that would take ages if we would go through every example. But yeah, tracking, like so there's this company called Sevio, and they do some like tracking in warehouses, like real-time information about location of different devices, if they're being used, etc. So you can imagine again, like real-time location information, like this asynchronous communication is super important in managing the warehouse. Like you can imagine, like let's say you have a group of forklifts, right, to move boxes around the warehouse. So as a manager that wants to have as efficient warehouse as possible, you can imagine a use case where you want to track how often your forklifts are moving. Like you want to see a chart that, for example, you have 5 forklifts, but only 3 of them are moving, or only 4 of them are moving. So you want to dig out any information like why at the current time we don't have all the equipment operational. Why for a few months one of the forklifts was not moving. Like how to investigate, how to optimize work at the warehouse. You can of course rely on humans that they will report how stuff works in warehouse, but yeah, I'm not going to advise to not rely on humans, but basically, like you don't want to rely on humans in these cases because they are busy with work at warehouse. So you don't want to ask them like to do a report, like daily report, how often they were using a particular equipment at the warehouse. You want to get this information right from every device. So you, like in every IoT, every device has some communication device next to it, and it's sending like every second or every 5 seconds, whatever, a message somewhere to a MQTT broker with information like, okay, that's the state of the forklift, that's where it's located, and that it's operational, let's say. And then on some side, on the other side of the system, you can collect this information and have a like build diagrams or any other way of consuming data to read from it, like analyze the data and learn from it. And yeah, last but not least, in IoT, I think the best example is drones. I don't want to relate to the war at Ukraine, but again, like drones are useful in many different locations. So yeah, there's a company that produces drones. And again, what is nice is that for their customers, let me close this unneeded tabs. For the customers, they don't only say, okay, you can take the drone, but you can actually program it. You get like the drone exposes an API that you can use to also, do some operations with the drone. And very interesting here to see is something that you're going to see with other examples is that it's very common that you build a mix API. You don't only do EDA or you only do synchronous communication. Sometimes you need both, because sometimes you have really easy, like this CRUD operations, so create, update, and delete. Update. Did I say update? But yeah, anyway, you know what I mean. So you basically create something in the system. So you say, okay, like I wanna create a new new track for a drone where the drone should fly to. So I'm just saying to the system once asynchronously, like, okay, please schedule a flight with a drone, and that's where it should go. But then sometimes you want to have also real-time information about, like, if it's actually operational, if it's flying, where it's actually located at the moment. And then you can react. You can have you can again imagine an application on your mobile that alerts you that drone stopped flying, or you lost connection with the drone, and you know that you lost connection with the drone basically because you stopped receiving messages, this asynchronous stream of messages from the drone, from the IoT device. So that's one of the, that's why I also put it first. I think it's for me, it's because IoT is it's not so fresh anymore. I think it's pretty good use case for Async API, and especially that we know that it is used in Async API. And also when you try to read more about Async API, one of the most reused examples of Async API is a street light. We always call, like, yeah, show me street light example, and it's like perfect IoT example. Like, it's because you want to have like IoT in on your streets with street lights. You want to know how given street light is performing, if the I'm not sure what's the English word for it. So the stuff, that bulb that gives you light, right? Basically. So the LED bulbs, they have some brightness levels. So you want to know, like, what's happening with the bulb. I'm not sure if LED is still a bulb, but yeah, anyway, you know what I'm trying to say. So in these cases, you want to know how it's performing. Like, if you need to send someone to the field to replace it, for example. Bob, oh, sorry, bulb, that's what I mean. B-U-L-B. Thank you. Let me see. So yeah, another use case, messaging, chats. So again, like in different systems, and I'll pick my two of my favorites from the list. One, like Slack. Yeah, I mean, everybody knows Slack, and we know that Slack is using Async API. We know they're still using, like, officially 1.0, but unofficially, at least I've heard some rumors that they, of course, plan to migrate to higher version. But it's always difficult. But yeah, Slack. It's the same situation like with the drones API. Sometimes you want to have the synchronous API. You want to, for example, create a room, right? Or create new user in Slack workspace. That's a typical synchronous operation. Like, you create it, you get a memo that it got created. That's it. You're not interested in anything else. But when there's a messaging happening in the system, like, you want to build a bot that will always check the message that is sent in a channel. So, for example, you want to use a semantic, not semantic, how do you call it? Sensitive, like, you want to check sensitiveness of the message. And I've saw it in few other communities, like, where it wasn't about sensitiveness, but it was similar concept. Like, when you drop a message, you want to drop a message in the channel, but then there's a bot that takes your message, checks it in a knowledge base, and gives you alternatives, like that there's some articles on GitHub or other resources that could answer your question. And you're being asked, like, are you sure you want to ask your question, or maybe the other resources already answered it? And it's possible thanks to this asynchronous communication that is part of Slack. So where you can actually connect to messages and see, like, real time what's happening, and react on a given message happening in the system. But my favorite ones here is Restream.io for two reasons. Personally, it's a Ukrainian company. And the second one, they support us big time because actually this whole live stream is supported by Restream.io. Like we are able to have a meeting on Zoom and show it on different channels, thanks to Restream that is basically sending stream to different channels. Now, if it comes to docs, they have exactly the same situation. So they do a mix. Like there is some basic API, like synchronous API, where you want to just have an operation like get something, like get information about live streams that you have scheduled, or you want to schedule a new live stream, or you want to create a new source where the live stream should be streamed. But there is also a WebSocket connection available where you can basically during the live stream you can connect to a stream of messages, like everything that I say, everything that happens with the live stream, the quality of the connection, all of this you can connect to it. As a developer, you can write a code that will actually listen to all the messages real time, and then again react. Like if one of the message says that the stream is unstable, like I don't know, I could have a message somewhere like for my privately some script that will ping me, hey, like we're noticing some issues with some stream, like you better check the connection. Or and as far as I was checking, you can also do some smart checks, like some like basically you can read the message that we're sending in the live stream and interpret it, and again say, you can even beep. Like if I would use bad words, you could, for example, think about writing a plugin that will again protect your community from using bad words, especially the one with bulbs that I was using. And then that's the use case. Like you can in real time, in asynchronous manner, get a message that you want to react on, and react and do something useful. Now, something that brings a lot of interest for me, at least, but I think many of us already heard about the fintech renaissance and all these different crypto platforms, trading, etc. That's a huge industry now. Actually, like when I was leaving my previous company, many people were just leaving to fintech startups. So I think it's pretty hype. But if you don't follow that much of the hype products hype technology changes, then let me just show you two examples. So the ones that I examined last year will be the ones that I will show you as an example. They are based on WebSocket. So that's the trend you can definitely notice in fintech. Like if it comes to public APIs, of course, we don't know what they're doing internally. But basically, public APIs, when they want to expose information about market data, all the currency value and trading, it's all exposed over the WebSocket, because you really need, like, I mean, you know, like how the market and stock options work. In crypto, I think it's even more unstable. So you want to know, like, really real time, what's the value, quickly calculate it and decide if you should sell or buy. You can't base it on synchronous communication, because then it means every single second, you have to ask the server, what's the value of this currency at the moment? What's the value of this currency at the moment? And again and again and again. And you can't have delay if you don't want to lose your money. So yeah, let's look on Kraken, because when I was writing one article, I was actually using them as example, because when I look at this old school UI, it reminds me of it basically reminds me of the different open source tools for generating documentation. So they are either using Async API 1.0, I think. That's my suspicion, but I never managed to contact anyone from Kraken. Or they are just reusing Open API, like cracking Open API spec to generate documentation. But yeah, that's just my my assumptions. But the most important, what you should know, again, like the Kraken, it's a trading platform. You can like basically you create an account like you create an account in a bank, and you, let's say you want to buy Bitcoins or you want to buy a Polkadot, and you want to basically be a better trader. So trade not only from time to time, but really real time. Operate on the market information, especially if you invest a lot in Bitcoin. I can imagine you want to have real-time information. So so they expose the WebSocket API. So you can, again, like create an account, probably pay for it, didn't check that, and you can have a real-time access to all this information about stock. So you can, for example, subscribe inside the WebSocket after having a WebSocket connection with the server in your client. From your client, you can send a message that you want to subscribe to information about XBT, not sure really what that is, if it's Bitcoin or whatever, and versus dollars and versus euro value, and what kind of subscription it is. And then you start receiving a stream of messages, basically, and the current information about the value. And then, of course, basing on the value of the message that you get in response, you can write some custom code that reacts to this asynchronous information that you just received in real time. And with Gemini, it's basically the same, and it's the same with all these platforms. Like the idea is, like, first of all, we have huge amount of messages that we need to share real time. The best way to do it is WebSocket, asynchronous, but some things, again, they need synchronous operations. Like the best example, like you're getting a stream of information about the value of the currency, and at some point of time you say, okay, it's a good value, I want to make an order. So you're not going to send an SMS message to yourself that you have to make an order, because it's, again, like you're going to be delayed before you do it manually. So the API that they give you is like you have a real-time stream of information. It's like what you can do in the system, but then you can do a synchronous call basing on the information that you received, like synchronous call. Okay, place an order. It's always a mix. And something that also complicates later the understanding of Async API and in general is that, like, in these cases, WebSocket is even used in a bit different way. It's WebSocket becomes a kind of message broker, because WebSocket has this feature where you can have sub protocols. So WebSocket is just to transmit information. The protocol is only used to establish the connection and transmit the connection. But then the messages, like you could see in the case of Kraken, there's just custom message where you can subscribe and then you receive messages, and you can unsubscribe and stop receiving messages, but still having the connection open. And these things are basically so-called sub protocols. So some kind of agreed way of how you actually, after getting a connection with a WebSocket, exchange information. So basically the WebSocket becomes a message broker. But yeah, let's not complicate our lives too much. Now, yeah, the next one is, yeah, the most secret one. So something that I talked about last time, like it's like, again, like typical broker centric. You have a Kafka broker somewhere in the middle, in your microservice architecture, like hundreds of microservices communicating with each other over a over Kafka broker. And this is the biggest. Well, like we know there's a huge adoption. We know many companies adopt it, but I mean, I've never seen, maybe in case of SAP because I was working there, but I've never seen a real final Async API document, because Kafka is always used internally inside these architectures. So companies, they're okay to share sometimes information that they use Async API, but it's pretty challenging to learn and get examples from them. So we, for example, know Walmart because an engineer from Walmart, she was presenting at Async API last year. We know that, for example, Bank of New Zealand is using Async API because they were talking at Kafka Summit about it. We know Adeo because one of the devs from there is actually a technical steering committee. We know SAP because I worked there. And we know that like in majority of cases, they need Async API also basically to expose the API, but internally to their different developer teams. So using Async API, they can build internal developer portals where team A can learn how they can, for example, plug in for a given functionality in the system because the other team internally shared their Async API document. So you know what you can use. People can even create like event portals where event catalogs where you can basically browse through catalog of the messages. So you're just interested to know like what kind of messages are floating in the system, and that's what Async API is needed for, and that's the most common use case. But again, like as you can see, the problem is I can't show you a real link. But yeah. You can at least see the talks from Async API conference 2021. And sports, yeah, it's this one is actually super interesting. I'm not going to go there because I think it's the point was made, but I'll just tell you, like again, like another use case for real-time information that you want to get from the system. Like there's a service that you can buy. So you're not actually buying any application, you're buying access to API that gives you an update from every sport, every possible sport out there in the world. You just buy access to it. You can use the API that they expose, and you can build your own application that, for example, is focused only on football, soccer. But yeah, I mean football, yeah, European football, for example. And like football from Poland, for example. So you want to build a portal where people can come in and see live scores from just Polish football league one. And instead of building the entire infrastructure of your scouts that go to every match and report how the game is going every minute, you can just subscribe to the services and use their API to get information about a given sport. Pretty nifty use case. But yeah, I think that we can basically summarize this whole rant about the use case for EDA is, again, it's like, it's whenever you're building a system that where you need a real-time information, and the amount of information that is in the system is so huge, and so many different entities consume and produce, that synchronous communication is a terrible overhead and super expensive. That's why you need asynchronous. So yeah, before we do some hands-on with APIs, any questions? Did you understand all the use cases? I can easily jump back to some of them and explain. Okay. no questions, then feel free after maybe rewatching recording, ask me offline if something was not clear. But yeah, next topic. So let's close some tabs. And next topic is get hands dirty. So basically, there's this API that is publicly available, which is Kraken API. So basically, we're going to play a bit with the fintech API. The only one really that I found where some of the endpoints are available without authorization. There are, of course, some limits, but at least like we don't have to go through the setup of the of some access and like paying for some services. There are two ways to play with the with this API. For WebSocket, I definitely always recommend WebSocket. So if you're experienced with synchronous APIs like REST APIs, you usually use Curl on your say CLI in your terminal. So WebSocket is basically a curl for WebSocket. And in the browser, unfortunately, I'm promoting kind of Postman being Postman employee, but I'm doing it even though there are alternatives because it makes me much easier to share with you workspaces, and you can actually much easier play with the API than with other existing tools that I know. So yeah, WebSocket installation, you don't have to install it now because it's you're just gonna have to go through installation unless you want to do it. So now we will just play with Postman as well. There are some installations needed. First of all, you need to access Postman. I think you have to create an account. I'm not sure if you can fork a workspace and use the workspace without logging in. But anyway, because in a browser, we're gonna do some WebSocket communication. You have to also install additional Postman desktop agent to actually be able to use WebSocket API inside Postman. So that's these are the prerequisites. So yeah, let's actually. So WebSocket is the first one. So let us do the WebSocket so you can see how easy it goes. Let me just move it to a side a bit. Just give me a. Oh no! Wait, I am sharing just my. Let me stop sharing for a sec, so I can actually share entire. Entire desktop. Okay. So you should be able now to also see the terminal. Can you see it? Okay, perfect. So let's do some arrangements. Okay, let's make it a bit bigger. So yeah, again, like thanks to Kraken folks, unless like someday I bet that they will see that I'm using their API for training and they will just shut it down. So use it as long as it's available. Like, so again, like WebSocket, it's just a it's just a terminal tool. So I'm using pretty old version 1.6, but it's enough. So first of all, yeah, from the documentation, like I'm not gonna go there, but if you recall when I was showing the Kraken documentation, again, like the first information you need to get from docs is like how to connect to the server. So that's the information that has to be for consumers of the API, for users of the API. That's the URL that is always provided in Async API document under servers key. So WebSocket, and yeah, let's provide the link to the API. So you can see like the connection was established. Let's make it a bit wider. Is established, and we even received from a system a first message, the event that is called system status. And again, from the perspective of the consumer, it should not be a surprise. It has to be part of, like in case of documenting with Async API, this message has to be described in the Async API document. I need to know what kind of messages happen in the system, and I need to know that there's an event called system status, which allows me to basically, first of all, when I start coding a real application that listens to Kraken API, I can be always sure, okay, like, so on establishing the connection, I always receive the status information. I need to know what fields are there, the connection ID, the event, the status. And I know, so, okay, whenever the message event is system status, I'm checking the status information. And if it's online, then everything is okay. So when I'm starting my service that listens to Kraken API, I can say, okay, I can drop a message in the console log like, yeah, the connection so far is pretty stable, like it's going a good direction, let's say. Let's make, now let's, the next stuff is that this API documents that they allow me as an API consumer to actually produce some messages to communicate with the server. So I can, again, like in my application, I can have some interval. So like every some time, send a message, like a ping message to the server to check if it's still actually alive. And I have to know that I can send a ping. Oh, and it failed. Let me start again. Okay, so I pasted probably something wrong. Or we were waiting for too long, actually probably waiting for too long because they also have, like, it's a free access API. So I did not interact it for too long. That's why they killed the connection. But yeah, I can send from time to time, like already you can see the usefulness of this information, that I can sing a ping and expect pong, because then I know everything is working fine, right? And then on the same connection, so we can already see this use case where you have only one entry point to the message broker, in this case that WebSocket is here. And then you can send and receive multiple different messages from the server, and that's where you would use all of feature in Async API to describe that, like on a given channel, you can actually subscribe to many different messages and receive many different messages. But yeah, let's send another message. Let's keep the connection also. Okay, it's already disconnected, but no worries. So we're gonna send a message where we want to subscribe to information about the currency value. And now brace yourself, because once I send this message, you're gonna actually see this this feeling of why the asynchronous is needed, why we need real time. What I mean by saying that there's a lot of messages in the system. So let's send. Okay, so we can see that now I told the system that me as a client, I want to get information about whenever there's a change in the value of the currency for this particular crypto and the value in the normal currency. And I'm receiving two types of messages. So one is the information about the value, and also regular heartbeat that lets me know that, like, yeah, it's actually, you're not receiving messages, not because we disconnected you, but like everything is fine. Like the heartbeat of the server indicates that it's running. And again, like if you can see these messages, they're super cryptic. And again, like that's what you have to specify. The user of actually the owner of the Kraken API, they need to be super precise. And they are actually in their API, but I think they do it manually. You need to explain like, okay, in the response, you're going to get a message, but it's as minimalistic as possible. So it's as lightweight as possible. So the keys, you can see they're just one letter. So it's as small as possible. So it's the size of the message is as small as possible. So it doesn't overload the wire that it's running over. So you need to have good docs, the schema information of the message that you will receive, and what value is hidden under what key, and how you should calculate these numbers. Like how do you should what operations you should do in your service to actually calculate what's the value of the currency. And then again, like during the running connection, I can say, okay, I want to unsubscribe from information about US dollars. I only want to receive messages about euro, because as you can see for now, it's USD, it's euro, it's euro, it's euro, it's USD, right? So during this real-time connection, I'm just sending a message. I get a message subscription status. So I get information that I got successfully unsubscribed. And then you'll see that I'm receiving only euro, no dollars at all. So it's like pure example of this real-time communication with the API. I established the connection with the API only once, and I get a stream of messages back and forth running in the system. And yeah, so as you could see, all the instructions are in the script. So if you didn't have a chance to play with it, just do it after the this kind of workshop. But yeah, let me just close it and quickly show in Postman, because like my plan is that, at least ambitious plan is that long term would be nice to have such a workspace in Postman where we showcase different APIs, as again, like to showcase like different examples of EDA APIs, especially that now WebSocket is supported. So Kraken API I provided here in this workspace, and an example, like, so much easier, you don't have to have CLI. So basically, yeah, so you have a ping the server, the information about Kraken API is already provided, the example message ping is provided. So I can establish a connection. So you can see the same message that I was receiving on my terminal using WebSocket. And then I have an example ping. So I can send ping, and you can see that I'm receiving pong. I can send ping again, pong, ping, pong, ping, pong, ping, pong, ping, pong. How cool is that, right? Ping, pong. Yeah. Anyway, I think more interesting is the example of actually subscribing for some market information. So I'm connecting to WebSocket, and I have some examples here. So I have this example of subscribe and unsubscribe. So again, let's maybe make it smaller. It's hard to see, but yeah, let's see. So let me send a subscribe. So yeah, again, you can see, again, like the stream of messages coming in from the system. And in the same connection, I can send unsubscribe messages. So I got a confirmation that I got successfully unsubscribed from USD. So these are just, actually, I just did the same thing I did with the WebSocket. But yeah, some people prefer terminal, some people prefer UI. And that's the hands-on. I definitely encourage you to play with it and get this experience of actually like seeing like what the hell is happening, like I subscribe and all these messages start coming in, like try to subscribe to many different currencies, not just two, and you're gonna see like the feeling of this real time and bazillion of different messages that happen in the system, and you want to know sometimes about all of them, sometimes about just specific one. That's why you need this pops up feeling. You're just subscribing to some specific information. Sometimes you unsubscribe, etc., etc. But also you need some additional information from the system, also in real time. So yeah, to summarize, it's 55 past. So we will finish with this. So summarizing what we managed to discuss with part one, we talked about APIs in theory. I think that at least my feeling is we managed to do APIs in real life, like in action, especially the event-driven architectures examples, and then playing with one of the APIs. So next time, next Wednesday, the same time, yeah, I'm right after this meeting, or tomorrow, I'm gonna schedule a new meeting, and we will talk about like introduction to Async API, some key concepts, at least from my perspective, and then we will create some first Async API document, and we should be able to finish with part 3 next week. Any questions before we finish? I lost the Zoom screen again. Okay, now I see it. No questions? You can still hear me, right?
Yes, we can hear you.
Asking 50 minutes after starting the workshop.
No, thank you. Thank you for this, though. It's pretty awesome that you're doing this. It's very helpful, too.
Okay, good. Thank you. So yeah, let's finish for now. We have actually, if somebody's interested, right after this live stream, we're starting a totally unrelated live stream about the work for Async API 3.0 version, if you're interested. And this, as I said, this part will be scheduled for next Wednesday, and information about all the meetings you can get from asyncapi.com. All the meetings scheduled for the next 7 days. So that's it. Thank you. See you next time.
Bye, Lucas.
Bye.